Today we're talking about the least common multiple. Some definitions. A multiple is the product of a number and any other whole number. For example, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So what I'm doing is I'm taking the number 2 and I'm multiplying it by 1, by 2, by 3, by 4, by 5, and I'm getting these multiples of 2. What it looks like in the end result is just you counting by 2. 2, 4, 6, 8, 10. These are multiples of the number 2. If I did 8, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and so on. These are multiples of the number 8, but what it looks like is you're counting by 8s. But these are all just multiples of the number 8. So that's what a multiple is. We are going to be finding the least common multiple, and the least common multiple is the smallest multiple that 2 or more numbers have in common. Some strategies to help you find the LCM, or the least common multiple, would be to make a list, to use prime factorization, and to use a Venn diagram. Here's what making a list looks like. So if you had the problem, find the LCM of 3 and 5. What you would do is you would take the number 3 and you would literally list out all the multiples of 3. 3, 6, 9, 12, 15, 18, and so on. And the number 5. 5, 10, 15, 20, and so on. You're looking for the smallest number they have in common. In this case, it's 15. So the LCM is 15. Sometimes making a list can get really lengthy, especially when you're using two numbers that don't quickly have a common multiple. So we can use prime factorization or the factor tree. So if you had to find the LCM of 12 and 15, I would take 12 and I would break it apart into its factors. I know that 4 times 3 is 12, so I wrote 4 and 3. Then I need to break down the number 4 because that's a composite number and I'm looking for only the prime numbers. So 2 times 2 is 4. So my prime numbers that make up the number 12 are 2, 2, and 3. For 15, it's 3 and 5. Simple as that. Now what I have to do here, which is different from GCF, is I need to pull out all my common factors. 3 was my common factor. So I'm just going to write it down once, and then I need to write down all the other factors that I did not use. I did not use this 2, I did not use this 2, and I did not use this 5. So I wrote down 2 times 2 times 5. What we're going to do is multiply all of those numbers together, and when you do that, you get the number 60. So the LCM of 12 and 15 is actually 60. If I made a list, that might have taken me a while. This is a shorter way to get to the LCM. Another way to do it is to make a Venn diagram. This is a better visualization of the factor tree. So I'm going to find the LCM of 16 and 20. So I need to ask myself, what times what is 16? I've got 2 times 2 times 2 times 2. And what I'm doing is I'm writing them inside this orange circle. But for now I wrote them here, and I'll place them in a circle in just 1 second. Here, for the multiples of 20, I'm sorry, not the multiples of 20, but the factors of 20, I got 2 times 2 times 5. So what I'm doing is I'm taking the common numbers between the common factors of 16 and 20, in this case, 2, 2, 2, and 2. Those are the common factors. I'm going to put them in the inside overlapping area. So each of them share 2 2's as their factors. The remainder of the factors of the number 16 will go in this outside area on the 16 side. The remaining 5 for the number 20 goes over here in the outside area close to the number 20. So you can see they each have two 2's as a factor, but they also have some factors that they don't have in common. This is important for us because we're going to take the ones that they have in common, and we're going to take the ones that they do not have in common, so all the other ones, and we're going to multiply all of those together. That's exactly what we just did in the factor tree, but this just looks a little bit different. So 2 times 2 times 2 times 2 times 5 makes 80. Again, making a list might be a little bit too much for these two numbers. That's why we have alternate strategies like Venn diagram or prime factorization. A little bit of application for us. Two faucets are dripping. One faucet drips every 4 seconds and the other faucet drips every 9 seconds. If a drop of water falls from both faucets at the same time, how many seconds will it be before you see the faucets drip at the same exact time? Same time. So we're doing the least common multiple. It's the first time the faucets are dripping at the same time. So that's your signal that you need to be finding the LCM. Okay, so I'm taking the numbers 4 and 9. I'm going to go ahead and choose to do a factor tree. So I have the number 4 and 9. Well, I know that 2 times 2 makes 4. I know that 3 times 3 makes 9. They do not have any factors in common. So what I'm going to do is I'm going to take each of those numbers and multiply them together. 2 times 2 times 3 times 3, that's 36. So it will be 36 seconds before these two faucets drip at exactly the same time on the 36th second. I want you to try finding the LCM using any method you choose. You could use a list, you could use prime factorization, you could use a Venn diagram, or you could change it up. So please do these problems for homework and bring your answers back to class.